Welcome to the deep dive. Today we're tackling something that, well, affects pretty much everyone who writes anything. The link between our working memory and writing skill.
Yeah, we're diving into a piece called The Capacity Theory of Writing. The idea is to explore how our mental bandwidth, let's say, affects how we plan, actually write, and then revise text.
Exactly, and working memory. It's not like that old short-term memory idea, is it? Like just a box holding 7 things.
Right, not really. The modern view, working memory,
Yep.
is much more active. Think of it less like a shelf and more like a mental workbench where you're actively juggling and processing information. It's about both holding and manipulating stuff.
Okay, a workbench. I like that. And writing itself involves different stages, doesn't it?
Yeah.
There's the planning,
Yep. Figuring out the what and how,
then the translating, actually getting words down,
putting thoughts into language, sentence by sentence.
and finally reviewing, looking back, fixing things up.
Exactly. And this research argues that our working memory, that workbench, is, well, critical for every single one of those steps.
Yeah. And for listeners tuning in, hoping to grasp things quickly, this should really explain why sometimes writing just flows, and other times it feels like pulling teeth, right?
Precisely. It often comes down to the load on that working memory at any given moment. How much can it handle?
Okay, let's get a bit more specific then. What's the absolute core idea of working memory we need to grasp here? Why is capacity the key word?
Well, the main thing is that it's limited. You only have so much mental energy or space, like RAM in a computer, and there's this constant trade-off
Trade-off between what?
between storing information and actively processing it. If you're putting a lot of effort into, say, thinking through a complex idea or finding the perfect word that's processing, you might have less capacity left just to hold on to other things, like the points you wanted to make next.
Okay, so you can't max out both storage and processing at the same time.
Exactly. It's finite. Try remembering a new phone number while also figuring out directions in your head. It gets difficult because you're pushing those limits.
Got it. Like having too many browser tabs open slows everything down. And you mentioned this isn't just writing, reading too.
Oh, definitely. Reading researchers have been wrestling with this for a long time. Even early models hinted at processing bottlenecks. Later work really zeroed in on how we hold the beginning of a sentence in mind while processing the end, to make sense of it all.
And in reading, there was this debate, right, about whether reading problems come from limited capacity or if inefficient reading skills cause the capacity to get used up.
That's the crux of it, yeah. One view, sometimes called domain-specific, suggests that if your basic reading skills, like decoding words, aren't automatic, they hog your working memory. This leaves less room for comprehension, so your reading capacity might seem lower.
Okay, specific skills taking up the space. What's the alternative view?
The other side argues for a more general capacity limit. Some people just have a smaller overall working memory workbench, and that limitation affects any complex task, including reading. They point to correlations. People good at remembering numbers often are good at remembering words, too. It suggests a central shared resource.
And wasn't there a sort of middle ground proposed?
Yes, some researchers suggested it's maybe less about the absolute size of the capacity and more about the efficiency of processing. How quickly and effectively can you handle symbols, whether they're words or numbers? If you're efficient, you make better use of whatever capacity you have.
Right, so efficiency matters a lot.
They did studies with sentences that are tricky, so-called garden path sentences, where you might initially interpret it wrong. They found people with measured lower working memory capacity seemed to stick with their first interpretation more.
Get stuck.
The idea is they had less mental space to hold the first interpretation and consider alternatives or use the wider sentence context simultaneously. They processed it more. Well, locally, or maybe encapsulated is the term they use. Less interaction with other information.
Okay, so less juggling of possibilities. Now, how does this relate back to writing? You're saying skilled writing is not like that.
Exactly the opposite, actually. The argument is that skilled writing is highly interactive and recursive. You don't just march through planning, then translating, then reviewing in a strict order.
Recursive meaning you loop back.
Precisely. Good writers are constantly bouncing between stages. While you're translating an idea into a sentence, you might suddenly rethink part of your plan, or you might revise a word choice based on the sentence you just wrote or the one you're about to write.
And there's evidence for this.
Oh, yeah. Studies watching writers work show this constant interplay. There's a great example of a wine expert writing a column.
What happened?
Even down to choosing a single word, he paused, considered his audience, that's planning, right, and decided against a technical term they might not know. So, Thinking about the reader influenced his word choice in the middle of, well, translating his thoughts. That's interaction.
That makes it really clear. Planning affecting translating on the fly. So if it's that skilled writing, what about less experienced writers? Or kids?
They tend to show processes that look much more separate, less interactive. There's this concept called knowledge telling.
Knowledge telling. Sounds simple.
It kind of is. It's basically retrieving information related to the topic from memory and then just writing it down. More like transcribing a stream of associated thoughts. There's less evidence of that strategic planning, goal setting, and shaping for an audience that you see in expert writers. Think of a kid just saying what they're writing, almost dictating their thoughts.
Like a direct download from brain to page, almost.
Pretty much. And the connection back to the reading research is interesting. Just like those low-span readers seem to process sentences more locally, maybe because basic reading wasn't automatic, less experienced writers might rely on knowledge telling because their basic writing skills generating sentences, spelling, handwriting aren't fluent yet. They take up too much working memory.
So knowledge telling isn't necessarily bad then. It's maybe a starting point.
It could be seen as an adaptive strategy, yeah. It's a way to actually produce text when your working memory is already heavily taxed by the fundamental mechanics of writing. It's less sophisticated, sure, but it's functional within those capacity limits.
Okay, this is helpful. Working memory limits can push us towards different strategies. Let's break down how these limits affect those three core processes, starting with planning. What does the research show there?
Well, first off, planning takes real mental effort. It's not trivial. Studies using dual task methods where people plan while doing something else, like reacting to a sound, show that intensive planning slows down the reaction time on the second task. It consumes cognitive resources.
Makes sense. You're juggling ideas, structure, and this applies to kids too.
Definitely. There was a study looking at children's story planning. They'd write a story ending with a specific sentence. The kids with better working memory scores were better at creating a plan that actually led logically to that required ending.
So more working memory allows for more constrained, goal-directed planning. What about tools to help with planning, like outlining?
Yes, outlining helps. Research consistently shows that when writers outline beforehand, the quality of their final text often improves.
Why is that?
Because you're doing some of the heavy organizational lifting before you start drafting. You offload that planning burden from the actual writing phase. Your working memory is then freer during translation because you have a roadmap. You don't have to invent and organize simultaneously.
The blueprint analogy again? Okay, what about just knowing how different texts are usually structured? Like knowing what goes in an essay or a story, does that help?
Yes, having those mental templates or schemas for different genres is really useful. Even for knowledge telling, a schema can provide cues for what information to retrieve next. But, and this is key, even if you know the schema, working memory limits might still make it hard to use it effectively while writing, juggling the overall structure and the sentence-level details.
Right. And for very young writers, planning might look quite different.
Yeah, it's often much more online. They generate an idea, write a bit, and that act of writing generates the next idea. It's planning on the fly. You might even see repetition in their texts, possibly because they're struggling to keep track and working memory of what they've already retrieved and written down.
Interesting. Okay, planning is clearly resource intensive. Let's move to translating, getting thoughts onto the page. You said it has two parts.
Right. Transcription, physical act, handwriting, spelling, and text generation. The mental part, finding ideas, words, building sentences, which shares a lot with speaking.
Let's hit transcription first. How does spelling, for instance, tax working memory?
Hugely, especially during learning. When kids are sounding out words, constructing the spelling letter by letter, that's very attention demanding. It uses up working memory resources. Once spelling becomes automatic, just pulling the word's pattern from memory, it's much less costly. In fact, early spelling ability predicts writing fluency, but that link weakens as spelling gets better.
So focusing hard on spelling a word leaves less mental space for thinking about the sentence or the overall meaning.
Precisely. There's a study where researchers compared what kids said they were going to write with what they actually wrote. Often, information was lost. The interpretation, the effort of transcription, handwriting, and spelling consumed working memory resources, causing them to forget or omit some intended content.
Wow, a clear demonstration of the trade-off. What about comparing writing and speaking output?
Yeah, kids often produce shorter texts when writing compared to speaking on the same topic. Part of it might just be the slower pace of writing, but the cognitive load of transcription itself is also seen as a major factor. It just takes more mental effort.
Does that extra effort ever have an upside?
Interestingly, maybe sometimes for kids, some research hints that the very struggle of transcription might make children attend more closely to the text they're producing, potentially leading to uh, maybe richer word choices or slightly better quality if they manage to write enough.
A surprising twist, but not always the case.
No, definitely not. For students with learning disabilities affecting transcription, that effort is a major bottleneck. It clearly harms both the length and the quality of their written work compared to what they can say. And experiments with adults forced to write in an unfamiliar script show it impairs their performance on simultaneous memory tasks. It underlines the resource cost of non-fluent transcription.
Really drives home how automatic skills free up our minds. Okay, that's transcription. What about the other part of translating? Text generation. Finding ideas, words, sentences.
Here, too, working memory capacity is crucial. Research shows kids with larger working memory spans can manage more complex sentences, coordinating more ideas within one sentence, and also manage coherence across longer stretches of text. Remember that study about writing to a specific ending? Working memory influenced how well kids could weave that constraint into their sentences.
And so the complexity you can handle in sentence generation is tied to working memory.
Absolutely. There was even a computer simulation that modeled writing development. By simply varying the amount of information the model could keep active, its working memory, they could replicate developmental differences in the text produced. And studies with older kids, like fifth graders, found working memory was even more strongly linked to text generation quality than to transcription fluency, suggesting its importance for the thinking part of writing.
It's not just the mechanics then, it's the core thinking. What about errors, like grammatical mistakes?
Yes, there's an argument that working memory limits contribute to things like subject-verb agreement errors, especially when the subject and verb are far apart in a complex sentence. Holding the subject in mind while formulating the rest, it taxes memory. Some studies have even induced more agreement errors in adults just by increasing the memory load during a writing task.
Wow, they could make people make mistakes by taxing their memory.
Yeah. And our own research using tasks, measuring how much people could remember while reading or listening, found that people with larger spans, especially on the listening-speaking task, were generally better writers, both kids and adults. The idea is that more fluent underlying language processing frees up working memory resources for the higher-level composition tasks. We also found skilled writers were faster at retrieving words they wanted to use.
So smoother language skills equals more available working memory for writing. Okay, that covers translating. What about the final stage? Reviewing or revision? How does working memory fit in there?
Revision typically involves 3 steps: detecting a problem, diagnosing what exactly is wrong, and then selecting a strategy to fix it. Working memory can be a bottleneck at each step.
How so? Starting with detection.
Well, if just reading your own text is effortful because your reading isn't fluent, it might consume so much working memory that you simply fail to notice errors. You're focused on just getting through the words.
Okay, that makes sense. And diagnosing the problem.
That seems particularly demanding. To figure out what's wrong, especially with meaning or clarity, you often need to hold the text you actually wrote in working memory and compare it to your intended meaning or the overall goal of the text. That comparison requires mental space.
Right, holding 2 versions in mind. What does research show about this?
Well, we know that simply cueing adults to the location of errors makes them much better at fixing them. But kids struggle more, even with detection. In one study, we cued errors for both college students and 7th graders. The cues helped college students fix both meaning-based and spelling errors, but for the 7th graders, the cues only really helped them fix spelling errors.
Why the difference?
Our interpretation was that diagnosing the meaning-based errors required holding more context in working memory, understanding how that sentence fit into the larger paragraph or text. The 7th graders, likely with smaller average working memory spans, struggled with that, even when the error location was pointed out. Spelling errors are more self-contained.
That highlights the demands of fixing deeper issues. Did you look at the types of revisions different writers make?
Yes, in another study with 7th graders, we observed their revision processes. The more skilled writers in the group tended to make more global revision changes affecting the overall meaning, organization, or flow. The less skilled writers focused almost exclusively on local changes, fixing words, spelling, maybe a single sentence.
And how did this relate to working memory?
The skilled, more global revisers also had significantly larger working memory spans. It suggests that having more capacity allows you to keep the whole text's goals and structure in mind while revising. Interestingly, for the less skilled writers, cueing errors sometimes seemed to make them focus even more locally almost hindering a broader perspective.
So working memory capacity might not just affect if you revise, but how you revise the scope and effectiveness of your changes.
Exactly. It seems capacity limitations can influence the very nature of the revision strategies writers employ, potentially locking less skilled writers into less effective surface-level fixing.
Okay, pulling all these threads together, what's the big picture view on working memory and writing development that emerges from this research?
The overall picture is that working memory capacity acts as a significant constraint across all writing processes, particularly during acquisition. That knowledge-telling strategy we discussed, it makes sense as an adaptation to these limits.
A way to cope when resources are tight.
Right. And while we can definitely teach kids more sophisticated planning and revising strategies, they often need substantial external support scaffolding to use them effectively.
Yeah.
This suggests that as basic skills like transcription and sentence generation become more fluent and automatic, they consume fewer working memory resources. That frees up internal capacity, allowing those more advanced strategies to be internalized and used independently.
So fluency in the basics is key to unlocking higher level skills.
It seems so. Transcription demands generally decrease for most kids as they develop, though it can remain a bottleneck for some. But text generation crafting coherent, complex language continues to demand significant working memory resources throughout the lifespan, even for skilled adults.
And the crucial point seems to be that working memory doesn't just limit how much you can do, but potentially what kind of processing you engage in.
Precisely. It might create a kind of catch-22 for developing writers. If translating is inefficient and consumes too much capacity, it hinders the ability to effectively plan and revise, which in turn makes it harder to improve the quality of translation.
So, our journey to becoming proficient writers is deeply tied to managing these working memory demands across planning, translating, and reviewing.
That's the fundamental connection this capacity theory highlights. Understanding these cognitive constraints really helps explain the developmental trajectory and the individual differences we see in writing ability.
It really makes you think. If we deliberately use external tools, maybe really detailed outlines, concept maps, or even advanced AI writing assistants to offload some of these working memory demands, could that fundamentally change the writing process and maybe even level the playing field somewhat, regardless of someone's inherent working memory capacity?
That's a fascinating question, isn't it? How much can we augment our internal capacity with external aids, and what effect does that have? Definitely food for thought.
Indeed. Well, thank you for joining us on this deep dive into working memory and writing. Hopefully this gives everyone a clearer understanding of the mental machinery at work behind the words we write.